Today we're going to learn about trig form of complex numbers. Now you've studied complex numbers in the past, and you have used this form, which is called standard form, where this is the real part and b is our imaginary part. So let's take a look at a complex number. Let's go with 3 plus 2i. We can look at this graphically on the complex plane where this is the real axis and here's the imaginary axis. And to sketch the graph, there's 3. Here's our 2i, so 3 plus 2i is right about here. Now this number has an absolute value. Now you learned the absolute value of real numbers, like for example the absolute value of -5 is 5 because that's the distance between 0 and -5. So we have absolute value for complex numbers where it's the distance between the coordinate and the origin. So what we want to find is the length of this segment right here. And one way of doing that is to look at this as a right triangle, where we know that this distance is 3, this distance is 2, so we use the Pythagorean theorem so the absolute value of 3 minus 2i is equal to radical 13. So now let's take a look at trig form. Here's our real axis and our imaginary axis. And let's say we've got, that's A and that's B. So this is A plus BI. Now if we draw a right triangle, we know that this distance is A, this distance is B, and this distance we can call R, and imagine that that's the radius of a circle where this is a point on that circle. So the relationship we have here is this, where r is equal to radical a squared plus b squared. Now in our picture we've got this angle theta. Now we can write two statements. We can say that cosine of theta is a over r, and sine of theta is b over r. If we solve, we get a equals r cos theta, and b equals r sine theta. Now watch this. Our complex number is of the form a plus bi. So let's rewrite that and say that this is in fact a is r cos theta and b is r sine theta. And then we still have I right there. Now notice that these have an r in common, so we're going to factor out the r. So we've got cos theta, and I'm going to reverse the order here, and I'm going to put the I in front of sine. I sine theta. And this here is our trig form, where this guy up here is our standard form. Now there's another way of writing this, kind of a shorter way. We can write trig form as r cis theta, which is short for r cos theta plus I sine theta. Now one more thing I want to point out before we move on to an example problem is that there's one more relationship here, and that is if we took the tangent of that angle, that would be equal to B over A, which is our opposite over adjacent. Okay, so let's say we're given a number. Let's say this is -2 minus 2 radical 3I, and we want to write that in trig form. That is, we want this to be r cis theta. Well, we need r and we need theta. So the way we find r is we have this relationship. R is a squared plus b squared. That's really just the absolute value of our complex number. So -2 squared, we get 4 plus 12, so the radius is 4. Next we need to find theta. Well, we know that tan theta is b over a. So here we go. Tan theta equals -2 radical 3 over -2. So tan theta equals radical 3. Well, we know that the reference angle must be pi over 3. But our number up here, a is negative and b is negative, so this is actually in the third quadrant. So to find a third quadrant angle that has a reference angle of pi over 3, take that reference angle, we're going to add pi to it, and we end up with 4 pi over 3. So we did it. We found r and we found theta. So now we just have to write our number in trig form, and there are two ways of doing that. We can write it the long way. This is 4 cos of 4 pi over 3 plus I sine of 4 pi over 3, or 4 cis 4 pi over 3. These mean the same exact number. Now we can also go in the opposite direction. Let's say that we're given a number in trig form and we've got to convert to a plus bi form. So let's say our number is 4 cis, let's go with pi over 3. Now what I like to do is I like to write this out the long way first. This is 4 cos pi over 3 plus I sine of pi over 3. And now we just evaluate these two trig functions. The cosine of pi over 3 is 1/2, plus the sine of pi over 3 is radical 3 over 2. Okay, let's distribute that 4, and we'll get 2 plus 2 radical 3i. Now usually we don't put the I after a radical, so this can be written as 2i radical 3. But that's our conversion. We went from trig form here to standard form over here. So today we learned that complex numbers also have absolute values. To find the absolute value of a complex number, we use the Pythagorean theorem. And then we learned about trig form of a complex number. That could be written two different ways. That's r cos theta plus I sine theta, or r cis theta. And then we learned to convert between the two forms. If you wanted to convert a number to trig form, you'll have to find r, which is the absolute value, and you'll need to find theta, and the way we do that is using the tangent ratio. And then converting to standard form, you really had two steps here. You wanted to evaluate your sine and cosine functions, and then the second step was to distribute r. And that's it for today.